This is Todd with Southwest Blinds and Shutters in Arizona. I want to appeal to the contractors, the interior designers, the custom home builders, and assist you with your process of finishing a home to the customer standards. And we would like to be fully immersed into the beginning part of the project all the way up to the end.
So Todd, when you go into new construction or remodels, what mistakes do you see builders or contractors making when they're wiring homes for shades?
Typically, the biggest thing is not following the plan, not making sure that the wires are not run to the right spot, making sure that the communication is key with the electrician through the process, and following where the wires are going to end. We've had wires that are run 6 inches outside of the spec of our shade, and at that time you're going to be cutting the walls open and running the wires back to them so we can hide the wires. The biggest issue when we go into these jobs, and the things that we find that are common occurrences, is the location of which the wires run and where they feel that the wire should end up, and where we dictate the wire should be, and then where the electrician can actually run it to in theory. And so that's one of the common occurrences, is when we go into the pre-planning stage and we say, hey, look, we need the wire 6 inches in and 1 inch back. And then we show up, and then, well, the electrician couldn't do that. He could only get 6 inches to the right of that, and he's out here in left field. But now all of a sudden, we need that wire to be here. And keeping on top of that, so when we walk the house and dictate where we need the wires to be run to, the biggest part of the process is that having the general contractor of the job make sure that the electrician or the contractor knows exactly why we need those wires in that specific location. Because we're not asking them to take it to an easy place. Again, as I referenced in the video, is know that there's a header there. There's a solid chunk of wood. And trying to run those wires or move those wires after the drywall is up and after the finishes are done is a nightmare.
So Todd, we hear a lot about the wires at the window need to be home run to a central location. Could you explain that for us?
So a home run dictates running a line directly from the shade. So here we have the wire coming out of the shade up there. So a home run would essentially be from this shade all the way back to this power panel box and then plugged into one port. With low voltage applications, daisy chaining, as you would do in a 110 application where there's more amperage, more flow, more consumption can travel through the wire. With a low voltage, you're sitting with a 16.2 gauge wire, which can only carry so much power to power up the shades consistently. Lutron will allow you to daisy chain 2 shades together. Some manufacturers won't allow you to daisy chain any shades together, and they will dictate that every shade has to have its own home run. If you try and double up inside the power panel with some lines, let's say pre-construction, we didn't think about square footage on a shade, and we find out that we can no longer do 1 shade for this large opening, that we have to break it into 2. And then we're trying to daisy chain or run those 2 together and have those 2 run through a 16.2 wire back to the power panel. Now let's say that power panel run is 40 feet. 40 feet is way under the maximum, and so we probably could confidently run that. But with the bigger homes now, 90 feet, 100 feet, 200 feet. And at that point, it's no longer about how much power that line can supply. It's how much can travel through it at any given time. And some of the things that can happen is when you go to raise both shades at the same time, they're both trying to consume power from that same line. They run themselves light because each one is trying to pull 35 watts from that line, and they're unable to pull it. So your shades will run slower, they'll be inconsistent, they won't travel together. So a home run is most important when you're running low voltage, because that dictates that this line is going to be dedicated from the power panel all the way to that shade. You're never going to have a power drop, a power loss consumption, because you have just one shade commanding power from that one line.
Todd, can you explain what a power panel is and where that ideally would be located in a home?
So a power panel is a bulk power supply unit. It's something that typically you're going to find it in a closet or a data server room We've put them in laundry closets, coat closets, anywhere that you can run a trunk of low voltage cables to, because be mindful that you want to run all of your cables to one location if you can. That way when we pull them out of the wall, it's a nice neat little bundle. Each one of those bundles will get connected into each one of these power ports through the side of the holes in each one of the in the box. And so when we look at a power panel, it's not the prettiest thing. It's not something we really want to put on display. You paid a lot of money for it, but it's one of those things you kind of want to just put the background and just let it do its thing. And so what we do is we typically will put them in closets. We've mounted them inside of garages where they're out of sight, out of mind. Just nestled somewhere out of the way that you're not going to have to see it. Again, we want it to be invisible. That's why we spent all the money to do low voltage. We want the power panel just to disappear. We don't want to see any wires coming out of the shades inside the home. And so the best job that we can do is hiding it inside of a data closet or a pantry or a garage, some application that's not going to be seen on a daily basis.
Todd, when you do a Somfy or a Lutron low voltage motorized shade job, what wires do you like to see installed in the home?
Typically what we'll ask the builder to run, or the electrical contractor, is a 16-2 wire. 16-2 wire is going to give us the power that we need to supply to the shades. If you're adding the implementation of the data communication, we would need to have a 16-4 wire. And it's kind of a little different because it's not actually 4 16 wires. It's going to be 2 16 gauge wires and also 2 22 or 24 gauge communication wires that are going to be shielded within the power supply. But typically what we would like to have run is just 16-2 power wire.
And can you show us the 16-2 and the 2 wires and explain them?
Yeah, so we have 2 applications here. This wire here is directly from Lutron. So this would be a 16-2 with the 2 communication travelers. These are both 22 gauge wires, the purple and the white. The black and the red are 16 gauge, which is why they call it 16-2 wire. This here would be the other style application. This can be found commonly anywhere that you buy low voltage wiring. This is just a 16-2 power wire. There is no data communication to this wire at all. Again, you just see the 2 wires that come out of here. Both of these are 16 gauge to supply the power.
And what's the advantage to 16-2 versus 14-2 or 18-2?
The 16-2 is what they find travels the correct amount of voltage through the wire. When you get into too big of a wire, it can deliver too much power to it. When you get into too small of a wire, the 16-2 wire, you can see in this configuration, if we went to a 14-2 wire, this bundle here is going to get quite a bit bigger because it's housing 2 larger cables, harder to bend, harder to maneuver around applications. 18-2 is on the brink of bringing your footage down. So instead of, let's say on a 16-2 application, you can run a cable 100 feet. If you go to an 18-2, which is going to deliver less power consumption, that may be brought down to 75 feet. So 16-2 is going to get you the maximum output and still the ease of running through the wall in different applications, keeping the sheathing of itself small.
So Todd, you go into homes where most customers would like inside mounted motorized shades. What happens if the electrician pulls the wire, say 6 inches above the window opening?
Well, in this application here, if we had this shade, this is an inside mount shade, and inside just reference the inside of the pocket or inside of the window opening pocket. Again, outside would be outside or above the pocket opening. We've come into homes where, if as stated, that the wire is ran outside of the pocket, which means the wire would actually come out of the wall right about here. Now you can see that being my shade is mounted here, the only way to get this wire from here to the shade is to run it across the opening, which means you would have a wire coming down the face of the opening and back to the shade. Or we can drill the hole and hopefully not hit the wire after construction has been done, and drill the hole and maybe fish it back out through the lower part, which is going to be extensive and time consuming. a lot of dust, a lot of patchwork. And so when that's done, the time consumption that's going to be involved in that, not to mention the shades cannot be installed at that appointment because the wire would physically have to be moved, which means the shade cannot be in the way for them to do all of the modifications to the opening to correct where the wiring is coming out of.
Todd, in some applications, do we ever need more than one wire ran to an individual window?
Yes. In a lot of applications, a lot of the larger window openings that we're dealing with today, customers are in need of multiple shades in one opening. Each one of those shades, again, like we talked earlier, is going to require having its own dedicated home run. In this application here, which is becoming more and more common, you would have two shades in one opening. You have a sheer on the front, and then you would have a blackout on the back side. Both of these would need their own dedicated home run. The reason being is when you go to raise this shade, as I'll show you here in a minute, if you're raising each one independently, it's not putting that much draw on the line. But if you ran a wire to both of these and tried raising both of them at the same time, again, they're both trying to consume that small bit of power from that low voltage cable, which can cause issues with the shade raising. Or you can have enough of a power consumption loss, depending on how far your home run is, that the shades won't actually operate. They're looking for a certain voltage when they're being commanded to do certain functions. And when you take from that, the communication is lost. Other applications where you might want multiple wires run to multiple window openings would be if you have a large opening that has 2 or 3 shades. So let's say that this opening here, these 3 openings here, were all just one large opening. And because it was really large, we couldn't get the fabric that the customer spec'd in the widths wide enough to do all in one. So we're gonna break it down into 3 separate sections. Again, you would be trying to run 3 shades off of 1 wire. Again, if you're raising just one of them at a time, most likely you're not going to have any issues. But with those types of shades, when you go to raise them, typically you're going to raise them all or none. And so it's when you go to hit the all button to raise them together that they're going to be trying to consume that same power out of that line. And it's not going to be available for them to pull from. In this application here, as you'll see in the video, as I go to raise these are both raising simultaneously. Now, if I tried to raise these simultaneously off of the same wire, the one may act or jump as if it's not receiving enough power from the power supply, and the other one may go up at a faster rate, typically whichever one you have wired in first. But this is a common issue where we'll go into a home, something that was wired well before we were even thought of, and we would now want to have this type of application where you have 2 shades in one opening and not be able to have the power that you need, which in turn would have the electrical contractor come back out to open up your walls to run additional wiring.
So Todd, we've been in some homes where the customer would like a cellular shade or a banded shade that's only available in low voltage, but the builder or contractor has run line voltage to the windows. So what do we do in those scenarios, and what's the problem?
Well, in those scenarios, if they ran line voltage, typically when a builder is going to run line voltage, by the way, is 110 volt or common household current. What they would do is they would run a naked wire to the opening. So kind of like this wire here without the plug end on it, and it would just have 3 wires that would come out of it, with the intention that the shade is going to be directly connected to the wire that is coming out. So they wouldn't run an outlet. If they did so happen to have the space to run an outlet, what we can do to fix the situation is order low voltage power transformers for each window application. But at that, you would need to have an outlet for each one. This gets, again, really bulky inside the window and takes up a lot of space, and most window openings in most homes that are being built nowadays don't have the room to have this inside the window opening itself. If somebody wanted low voltage honeycombs and the line voltage was run, the only two ways to fix it is either to transform them and have an outlet mounted inside every window opening, or have all the shade or all the wire pulled and have the correct wire run to those locations. No honeycombs. There's a lot of products out there that will not run directly off of 110 current. Some of the larger 110 roller shade motors will run directly off of 110 current. But if you're looking for a honeycomb application, the motor and the capacity doesn't dictate having a line voltage directly to the shade itself. It would be transformed in some form from 110 down to 12 volt to run the shade correctly. Okay, so in conclusion, as we just spoke about with the low voltage wiring and how we run the different applications and what we're looking for, the big premise of this conversation is to shine a light to the pre-planning stages. Think about this before you get to the point where there's no one going back and then you're going to be forced into an application that you may not want. Reaching out to one of the designers is going to give you that ability to touch base and let them know what your goal is, what you're trying to achieve, and at what part of the staging plans that you're in. And this will give us the information to help you build the project correctly. So when we come out to do the finishing touch at the end of your project, everything will go perfectly. So the reason that we talk about these things is because I have an installation team that's top-notch, and they take great pride on completing the project the first time out. As the customers can come to appreciate when they're scheduling time to be at their home for us to come out and install their products, they don't want us to have to repeatedly come back for small issues, things we forgot, things we overlooked, things of those natures. And so with Southwest Blinds, we build processes. We look at different scenarios and how they can take place, and we look to make them the best that they can possibly be. And so as you'll come to know when you decide to go with Southwest Blinds, from the start, from the very start, from the initial contact in the office, they're very warming. They want to ask you certain very specific questions to get a general idea, so we can, when we have the designer come to your home and walk through the different products with you, that we know that we're doing the right thing by you, and that the end result is going to be a project that's going to be completed on time, in your budget, and the first time. With installers, we are rated by the completion rate that we successfully complete our jobs at, and my guys take great pride